As you watch this video, I encourage you not to try and copy every single thing that is happening in this video. What I do encourage you to do is look through it and then take some time to print your own blank copy of a unit circle and practice filling it in. This is one of the things that's going to be very handy for you, and you'll start to memorize the different aspects of the unit circle, which is going to help you make quicker calculation in terms of the trigonometric functions. What we in particular want to look at for this section is the graph of sine and cosine. In order to do that, we're going to take a completed unit circle, and just to show you how you would go about filling this in, this one's already filled in. Remember, the x and y values correspond to the cosine of theta and the sine of theta. And if you remember, the cosine of 0 is 1. The sine of 0 is 0. So that's our x and our y value. But let's just pick a random angle. For example, let's consider 5 pi over 6. If you remember, we first have to find this reference angle. This reference angle is going to be pi over 6. So if I draw a triangle and consider my reference angle of pi over 6, and if it helps you, you can draw it so that it matches the unit circle in terms of its orientation. Remember that pi over 6 value is going to give this to be a pi over 3 value, which results in relationships of 1, 2, and square roots of 3. Those are ones you need to quickly memorize. And this gives us a cosine of square root of 3 over 1 and a sine of 1 over 2. And it should be square root of 3 over 2 there. Sorry about that. Adjacent over hypotenuse. And if you notice from the chart here, the cosine, the x value, is negative square root of 3 over 2. And we have to know that from the quadrant that it exists in. And then the sine is 1 over 2. And if you remember, all students take calculus. So notice here, all of your y values are positive. Here, both of your values are negative, but the tangent, if you remember, is sine over cosine. So a negative divided by a negative is positive. And in the fourth quadrant, all of your x values are positive, or your cosines. Again, I highly encourage you to go through a unit circle and practice filling that out. If you need some help, come and see me. I'll be glad to help you. What I have done now is I have taken these values from the unit circle and I've created a chart. The x value, we're going to start using x now more instead of theta, so we're referencing real numbers. And then I've listed the sine and the cosine, or the y and the x values coming off of the unit circle. What I want you to see is that when we get to the bottom here, if we were to continue to 12 pi over 6, which results in 2 pi, we get back to here on our unit circle. And so the values are just going to repeat. Then if we come down and plot these values, here we have sine, here we have cosine. What you're going to notice is it never goes above 1, never goes below -1, and it repeats. In contrast, cosine starts at 0, 1, again, mimicking that point here when we're translating it into 2 dimensions. 0, 1, because cosine is 1, and then it comes down to -1. If we put these on top of each other, so here we have sine, let me get a better color there. We have sine and we have cosine. Notice they act very similarly. They're just a little shifted from each other. We can define these that their domain for both sine and cosine is going to be all real numbers. And their range, if you notice, is from -1 to 1. It repeats over and over and over. And if you notice, from here to here is where the repetition starts again. And likewise for sine from here to here, they both have what we call a period of 2 pi. That's how long it takes them to repeat. I encourage you again to print off a unit circle, take some time to practice filling it in, and then maybe place them on Desmos with the graphs to see how sine and cosine relate to one another and where those points translate from on the unit circle.